Swayam Prabha. Digital India. Educated India.
Welcome to the course, Environmental Impact Assessment, and today we are going to look at methods used for coastal ecology and to assess geomorphology. So we'll look particularly the segments of impact prediction and evaluation. So accordingly, our coverage, we will cover, we'll look at different sources and types of impact for used for coastal area. And then we'll look at the methods for impact prediction and assessment in this domain. So accordingly, our learning outcomes will be that after completion of this particular session, you should be able to identify different sources and types of impacts for coastal areas. And then you should be able to identify and select methods of impact prediction and assessment. So we're not going to get into too extensive details of the methods, but we'll look at what are the different methods which are available for the domain. So the key reference for this particular session, for this particular theme is Chapter 7 from the course book, which we are referring, Methods of Environmental and Social Impact by Tharibal and Wood. And we are also looking at the manual by Ministry of Environment. In this, we are looking at the manual, which is particularly for the ship-breaking yachts, so somewhat it relates to the coastal area. So we'll be looking at that as well, and then I'll be also linking some of the case studies for your reference, which you can further use for detailed understanding. So when we look at impact prediction, the key approach which we identify for impact is we undertake consultation, with public, we take consultation with marine users and the regulatory authorities. And we undertake a review based on the survey data, and then we also look at similar cases, references, analogous cases from where we can refer that what has happened in the previous cases and what is likely to happen in your particular case, the project for which you are preparing the impact assessment. For coastal ecology, a structural approach is required because one, as we have already seen in the previous session, that the geomorphology and the processes involved are very complex. So we need very structured approach, and for this, as per the textbook, what we see by Tharibal and Wood, it is suggested that one needs to undertake assessments separately for hydrodynamic effects. So what kind of effects would happen to the water environments? And the other, you would also look at the ecological impacts. So what impact would happen on the ecology? So these two segments, you look at it differently and you look at it in a very structured manner. And if you take note, there's the difference between the terms used. You will see that hydrodynamics effects, and then the other is ecological impact. So when we say that, there's a difference between that, because any change in the hydrodynamic would not necessarily mean impact. So there might be changes, but it would not have any kind of adverse impact on the ecology or the environment. So one needs to understand what kind of changes are happening. That's why the term is used, effect. But then because of that or otherwise, what kind of impact might happen on the ecology. So that one needs to understand the difference between the two. Further, when we say that it has to be taken in a structured approach, then we see that one needs to identify the effects and potential impact, as phase 1. Then one needs to describe different effects and impacts. So we have been seeing that you undertake baseline assessment, then you describe it, and then you assess those effects and impacts, and then you derive the impact significance. So we are going to look at how you assess the effects or impact, and then how do you really derive the impact significance. Just to quickly look at what are the different sources of impacts in the coastal area. So one of the major cause what we see is the urban or the industrial or the commercial development along the coastal areas. So they are seen as causes of impact. And then the kind of impact which it has, it's like it creates like increase in water temperature, at least at the local level, and that would have a secondary impact, like it would change the biota of the area. And then the same things could also change could lead to habitat loss. It could also lead to fragmentation. It could also lead to damage of the littoral and sublittoral areas, which we had already seen in the previous chapter. And this might happen because of occupying the land for a certain development purpose, and then also changing the drainage pattern, what kind of pattern you're developing, and that might also lead to certain like blockage or creating a situation which might lead to flooding, or creating situation which might lead to erosion or create disturbances, especially for birds. So urban, industrial and commercial development kind of land use changes which happens can also create these kind of impacts. And then when you look at such kind of land use change, especially when urbanization takes place, you also notice that there is increase in the runoff, including like you might also see flash floods where like rapid water would accumulate, so it would lead to flash floods during these storm periods. And then you would also see soil erosions, which would further lead to would have another secondary impact, like suspended sediments. Load would increase, and that would lead to increasing sedimentation in the estuary system. And then further that would you would be required to remove that by dredging, and you might need to regularly maintain that for the navigation purpose. So those kind of impacts are also seen, and then you would also see the nutrients and toxic pollutants coming from the urban areas, again loading the estuaries and the marine water. Further, you can also see bioaccumulation of toxic pollutants. Bioaccumulation, if you remember, we had studied about bioaccumulation of the toxic pollutants by the coastal and marine organism, and this would also happen, which would again have impact on the organism as well as on the human health. So it would have impact on the physiological, ecological impact as well as impact on the human health. So that can also happen. And then even eutrophication would happen because of the sewage effluents from the urban areas, and which might impact the estuarine and nearshore coastal waters. So that would also happen. We have already seen eutrophication, so I'll not cover that in detail here. Further, the nutrient inputs above certain extent would also lead to oxygen depletion, and that might also lead to death of fish and benthos. So that can also happen. And then also if the proportion of nutrients also change, then that might also lead or impact the food web, and also lead to increase in the algal, and then that can also affect the bird population. So you see these kind of range of impacts which take place. Then whenever development takes place, we occupy land, we have land claim. And then in that also leads to all these kind of changes, habitat loss, fragmentation, and so on. And you would see even the tourism or recreational activities would also lead to habitat loss, fragmentation, and damage of the littoral and sublittoral areas. So when you really take up the lands, or you have key impacts associated with the reclamation. So when you try to do the reclamation, like you try to take more land for the development purpose, that also has key impacts. So if you look at the direct impact includes the intertidal impact, and you would see that there is subtidal habitat loss, and then when that kind of loss happens, that has implication on the birds and fish feeding, and then the nursery grounds. So how the population grows of the birds and fish also gets impacted when the reclamation happens. And then you also see when reclamation happens, there is change in the hydrodynamic process, and then the pattern of sediment transport, how the sediment moves from one place to another is also impacted, and then that affects the erosion and also affects the accretion. And then you also see that there's effect on the tidal range, what range of tidal comes there, it also affects that. And we also notice noise problem, which eventually affects fish species and marine mammals. Then looking at the problems associated with tourism and recreation, one would see that you must have traveled to a lot of places and coastal areas which are very popular in terms of tourist destination. So you would see that there's a lot of direct impact where more and more visitors come, then it really affects the sensitive ecosystem, and it also affects the sand dunes in particular. So you will see that when the vegetation over the sand dunes are damaged, often it is said that to what extent it is damaged is quite possible that it's irreversible, and then it mostly loses the kind of ecosystem services it provides. So if you can recollect what kind of ecosystem services we talked about, so all that can stop. It can deteriorate the kind of services that the area ecosystem it provides. And because of a lot of infrastructure development, kind of jetties and other things you develop there, it also increases the disturbance kind of pressure which is created over the wildlife, especially birds, and they are especially they rely a lot on undisturbed sites for the feeding purpose. So those disturbances happen. Further, we see other causes which are like sea defenses, at sea defenses. When we say sea defense, means there are chances of all kind of disasters, cyclone, typhoon, and things like that. So you generally have protective walls and water breaks and other things. It can be hard structure, or you can have harbor walks or barrage schemes and so on. So these also, when these are built, they also have primary and secondary impact. So they can impact the flooding, or can also lead to waterlogging behind the structure. So wherever the structure is coming, the water which used to flow into the ocean would be blocked, and it would cause flooding and waterlogging behind the structure. And that would also lead to change in salinity, change in biota again. So those kind of things can happen. And then it would also lead to removal of tidal activity. So the tidal activity which was happening without any barrier there would now be altered, or would be removed from that place. So that would also happen. And tidal activity, currents and waves would be removed or they would be changed because of the structure which you're building there. So that would lead to another level of deposition or erosion, and it would also lead to change in sedimentation, change in the nature, like increasing erosion. You might also see loss of land and habitat because of erosion and flooding. And then you might see increasing sedimentation, and you might also see damage happening to biotypes. Biotypes especially which require clear water. So in the previous class we studied about biotypes. So looking at barrage types, we see there are two basic categories of barrage, which we see. One is impermeable and permeable barrage. So one of the example is Thames Barrier, which provide flood defense against high tides and tidal surge. So they use it as per the condition and situation, so it allows a lot of flexibility. So in the picture you can see the Thames Barrage, which is like controlling how the water waves comes, and also protects the entire city from the flood or any kind of disaster risk which is there. So that's the one example. Another example, if you look at, is of the impermeable barrage, is Cardiff Bay Barrage. So it is said, like so the Thames Barrage is said to be having lesser environmental impact since it's very flexible. But on the other hand, Cardiff Bay Barrage is to a certain extent criticized for its environmental impact. So it has had led to exclusion of tide, and also exclusion of tide, especially for the amenity purpose like water sports and for the consistent view, waterfront development and so on. And the impact of this has been like, there has been loss of marine habitats, loss of mud flats, and also impact on the marine coastal flora and fauna. So in the picture you can see the Cardiff Bay Barrage here. You can see how the entire area is divided. And the another document which we see here from the UK government is like, which helps you to look at the key potential impacts of barrage. So here I've given you the link here from where you can download this document. So you can see that how impacts of barrage are there, like in the domain of water, surface water hydrology and channel morphology, surface water quality, and then how how different phase of the project, like the construction phase, the operation phase, the decommissioning phase, has impact on the water environment. So you can see how during the construction phase you can have use of vehicles, machineries. They can impact the increase in the surface runoff from the soil compaction. Then you can see the change in flow velocity, increased erosion and subsequent changes, the increased flood risk, and so on. So you can see here how it's also giving you like how you can use it at to identify different impact, that you can see what impact will happen on land, like you have landscapes, soil, geology, and during the construction phase what can happen. You can have creation of new landform, you can have visual impact. Then you would also see erosion and exposure of the soil, and then you would see the removal of rock by excavation work. Likewise, you see all these in the operational and decommissioning phase as well. You see at the flora and fauna, and then how it affects the human environment. So this link from where you can download the document, I have given it to you. And when you look at permeable barrage, that normally takes like it works on the tidal power in order to generate electricity. So usually they change the sedimentation pattern and reduce the tidal activity upstream. So they reduce that activity. So they change the tidal activity, and it has the potential to also increase the chances of eutrophication. You can also see here in the Rance estuary in France, also you can see how there are studies which tell what kind of changes have happened. Then you can also look at Shiva Lake tidal power station, which is one of the largest built in the west coast of South Korea. You can see in the image how extensive, large scale project it is. So you would also find those things and how it affects the environment there. So the other causes range of projects include offshore renewables that you use, like you have dredging. So that also has a lot of impact. You also you see the alteration or removal of the tidal activity, currents and waves. It also leads to altered balance between the deposition and erosion. You would see decreasing sedimentation, increasing erosion, loss of land and habitat, and increasing sedimentation. Then you would also find noise, collision impacts to marine mammals, birds, fish, and benthos. So you see that. And then because of the development of the catchment areas also, like especially in the estuaries, due to these development activities, including like taking care of the urban, industrial, agriculture, forestry, any construction work like dams, check dams, and so on. So that also lead to increase in the nutrition and sedimentation load, and then the chances of eutrophication also increases. It also increases the chances of disruption of the food webs. So likewise, you also see another important area is the offshore oil and gas exploration, ports, terminals and shipping, marine fish farming. So you see these activities. So they also lead, like you're seeing how oil and gas exploration is happening. So that also has a direct impact on pollution, like you have organic matter, microbes, pesticides, and other things getting into the water. And because of the kind of activity happening, and also like you have effluents which are going into the water, and then there can be also incidences or accidents which can happen with the oils and other things, and which is said to be one of the greatest threat to the ecology. So it could damage the benthic ecosystem, and it could also it could lead to loss of life in loss of wildlife, animal life, birds' life in the coastal areas. And then you also see bioaccumulation of toxics because of these projects. And then the other cause, what we see, is the water abstraction. So when water is abstracted, it leads to lowering of the water table, including those in the freshwater ecosystems and wetlands, groundwater contamination by salt and pollutants through seawater intrusion. And then you will also notice some of the causes are overfishing, like you have seen all the industries we talked in the environmental status time. And then that also leads to depletion of fish stock and disruption of the food chain. So these are different kind of impacts which you see from different sources. And then you might also hear about another term, which is like coastal squeeze. So there's also another problem with whenever the defenses or any kind of structures are built across the coastal line. So when we say coastal squeeze, it's the loss of intertidal habitats due to the rising sea levels, and where defenses limit the ability of the frontage to roll back. So because you're putting the defense, so whatever water which comes and goes back, it's being stopped. So that leads to loss of intertidal habitat, which puts freshwater habitats into risk, and then risk which are like developed behind the sea walls. So here I have put a link to a video where you can see this coastal squeeze mechanism, and you'll try to understand what's the problem and how it happens. So I've given this link in the suggested read and watch. So looking at dredging, dredging is like really one of the area which has impact, and then dredging is done for many purposes. Like you have, whenever you're extending the harbor, you're creating the new ports, or you're creating navigation channel, or you're just maintaining those channels. So for that purpose, the dredging, for many of those purposes, dredging is required. So when dredging is done, it has several impacts. When you look at those impacts, you see that it increases the turbidity during the works, which may reduce, like lesser light would go, and if lesser light would go, it would affect the production and the visibility in the water, and that would also lead to changes in physiological responses for some of the organism. And then you also see that there might be release of toxins and nutrients, and then there can be physical damage also, and there can be also problems with the material which are released after the dredging. And by the act of dredging itself, you might deepen the inshore waters, and then you might create very sharp slopes which might make waves to really break through the structure, and then you are exposing the area for making it more vulnerable to risk. Further, we see that climate change can also impact all the processes. So we have been seeing how climate change, what are the impacts of it. So that can also change the impact. It can also impact all the processes which we are seeing. So we would also notice that because of the wind farm also there's impact, and it influences the geomorphology, it influences the ecological structure, and it can influence, wind farm can influence all of these at the different phases of its life. So usually one sees that there are short-term disturbances of seabed during the construction of the wind farm, and then it might also create sediment plumes. At the landfill site, construction activities may result in short-term changes in the sediment budget also. So you may note the term sediment budget, how it works, how much it really keeps on adding on. And so any kind of development can reduce or hamper these processes. And decommissioning can also can influence, but however it is considered that this decommissioning is like really the least dreadful in terms of impact. So we see that wind farm, the major impact happens at the construction stage, and especially from the ecological point of perspective, and especially because of the local disturbances which it causes, and then also the piling work also can create noise, underground noise. So which we, if you remember, we had seen it in the very first week of our lecture. And then there can be chances of collision, there can be changes in the fish population, and then it's also suggested that that commercial fish activity also has a lot of impact. Now, looking at the oil and gas exploration, so that if you look at that, what nature of work happens, oil and gas exploration, so where you lay pipelines, you have construction of offshores, rigs and onshore terminals, and then when the function is done, there's like decommissioning also. So that also causes local disturbances to the marine species and ecosystem. The biggest hazard which is seen is the accidental release because from the oil and gas exploration. So the transport of oil by ocean going like tankers, the ship and all what you see is said to be the most evident pollution which can happen, and that mostly, and it can happen because of the accidental spillage. So we had also seen historically how we started taking care of it. And then you also see ballast water and biofueling also has significant risk with shipping. That problem also is there. And then you would find guidance in this area where you have convention and recent marine biosecurity planning guidelines. So you can see I have given you the link from where you can look at the guidelines which are provided, how you can do all kind of identification and assessment. And then you would also find the National Ballast Water Management requirements. So here again you can see this. And then the other cause is the marine farming, and in India particularly it's important in Kerala area, and the tide is used to help harvest like shrimps, and like there are 75% of the farmed shrimp is produced in the Asia and China and Thailand, on all these eastern areas. So that's also caused a lot of, that also has impact. So we had seen range of impact when we studied about the environmental status. So marine farm that has high potential to lower the water quality. So it can impact the water quality because of the cages which are created, and one relies on chemicals and pest control and so on, a lot of medication which happens. So this water quality goes down, and then you can have pollution of water columns, and then you can also see seabed pollution. And then this is also noticed that the parasitic lice, like they can be parasite also, and then there have been cases where fishes, salmon fishes have died because of the increase in lice and other things. And then the water abstraction also you can see has impact. Water abstraction, it leads to saline water intrusion, and saline water intrusion can have other kind of impacts. So you can have it can lead to pollution in the seawater. Then you can also have it can also affect the biota of maritime fresh or the brackish water habitats. Then you can also have cumulative impact where abstraction as well as infrastructure, they can also cause a lot of other things. And one notable thing is the sinking of the land to the sea level, which also we had studied before. So all these can lead to that. So this manual by ILFS, by the Ministry of Environment and Forests, Government of India. So if you'll see that you undertake all these information, like the basic information about the project in you can see in number 1. Number 2, you would see all the kinds of natures of activity which goes, and it provides you with the information checklist confirmation. And then you see what kind of natural resources are used for construction of the operation of the project, use of storage, transport, handling, or production of solid waste during construction or for operational decommissioning, and then the release of pollutants, any hazardous, toxic or noxious substance to air. Then you can see generation of noise and vibration and emission of light and heat. You can see risk of contamination of land or water from release of pollutants into ground, into sewers. Then risk of accidents, factors which should be considered. So you can consider such as consequential development. Because of one development, other developments would happen. So cumulative impact. So you can see the lead to development of supporting facilities, all the ancillary facilities which might come. And then if you look at the choice of methods for prediction of impact, you would it also provides you that. So you have for the water environment, you see estuary models, estuarial dynamic models. So we have seen this briefly within a water environment also. So dynamic water quality models. So you can see this. I'll be sharing this document with you. And HEC2, SMS, all these gives you modeling choices like model which you can create to do the assessment. So looking at the methods of impact prediction and assessment, so you see that the choice of methods for prediction of impact for water environment has been provided by the manual. So you can look at the estuary models, and then dynamic water quality model, HEC model, SMC models, which are there. So if you'll see how they are applied, it stimulates tides, currents, discharge in the shallow, vertically mixed estuaries. So these models are available. And like you will see dynamic water quality model, it stimulates the mass transport of either conservative or non-conservative quality, how that entire hydrodynamic model will work. And then you have HEC2 to compute water surface profile in the steady situation, gradually varying flow in both different kinds of channels which are there, and then what kind of circulation, salt water intrusions would happen. So all these models can undertake that work. And then you have models for noise environment impact assessment also within this. So you can see Federal Highway Administration, FHWA, has a model which helps you to noise impact due to the vehicular movement that you can see. Then you also have Dhwani model, and then you also have hemispherical sound wave propagation airport. That model is also there. Then you would also find model for land environment. So you have digital analysis technique, ranking analysis for soil suitability criteria. So this can be used. Then you also have for biological environments like sample plot methods. So we have seen these transactive line intercept methods, plotless sampling methods, species list method, direct contact method. So all these we have seen. So I'm sharing this example also, case study also with you. So you have this image, you can see Sacramento River flow reduction analysis, which they have done. So diversion from what kind of fish passage would be created. So in the figure you can see simulated operation period and rated flow through fish passage. So they are working on the different scenarios. Scenario 1 you can see, and how that like by year wise 1970, 1971 and so on, 2015, what kind of change would happen, a flow range of passage would happen. So in month wise also on the left hand side vertical axis you can see the variations. And then in this again through this report you can see how they are working out the flow reduction analysis. So you can see how within all months, Jan, Feb, March, April, what kind of flow reduction would happen in the wet, above normal, below normal scenario, and then you can see which are the considerable variations as per the scenario. So these models are used, so you are familiar with those models now. So once you identify the impact, you undertake impact assessment. So now you need to really understand how significant is that impact. So an impact arise and whenever there might be a lot of things happening, but the impact happens when a particular effect interacts with the receptor. And those changes can be positive or that can be negative. So that is what you check. And especially in the impact assessment stage for coastal or marine ecological assessments, you look at the nature or the magnitude of what kind of impact is going to happen, what's the nature of the impact, how sensitive is the receiving environment, and that all understanding you have to develop. So while looking at that, you look at these questions, and you remember how we have looked at these questions before also. So while assessing that, you look at it. So what's the scale of change which is happening, and will it how much is the change? Then the spatial extent and what kind of duration is there, and whether that is reversible or not, what's the frequency of the change, and what's the likelihood of whatever change you're thinking of that might happen. And then looking at the receptors thing. So how vulnerable is the receptor, how sensitive or intolerant the receptors are. So just to quickly revisit what really sensitivity means and what does recoverability means. We have seen all that in our previous session. So you also see that there are a lot of criteria which are used to determine and look at to assess the impact, so whether they are significant or not. So like here in the table you can see whether the magnitude of the impact, whether it's high or not. You have certain sets of questions. So here you can see, I'm just going to tell about one of that parameter. So the quality and availability of habitat and species are degraded to the extent that locally rare population and habitats are destroyed, and protected species and habitat experience widespread change, such that the integrity of the ecosystem and conservation status of the designation may be compromised. So in such situation, you consider that to be high. So it is going to change, the integrity will be disturbed and it will be compromised, then the impact would be considered high. So likewise, you would look at where the integrity is not much compromised, it would be considered as medium, and where it is recoverable, then it would be low, and then a certain extent very low. So you see that you look at those questions, and same way you have another example where you look at the sensitivity of the receptor. So you also see when do you see that there is high sensitivity. So you look at a receptor, what's the key characteristic of those receptors? Are they distinctive or not, and are they like specially protected areas or protected species? So what is the value of it, and how sensitive are those receptors? Can they adapt to the change or not? So if not, then their value would be high. So likewise, you have certain medium where you will say the impact is medium when the value is relatively low, and then the sensitivity wise they have the capacity to accommodate to the changes. So likewise, you will see the impact is low when the value are of local importance and not designated anything, and then the sensitivity wise also they are able to tolerate and they are able to adapt to the changes given, and similarly very low. So that is how you would have parameters to evaluate all the significance. So here, as per the manual, you can see how they are looking at the environmental sensitivity, again taken from the shipbreaking yard example. So you would look at certain parameters given here. In the Indian scenario, so you have areas protected under international conventions, so you would consider it to be more sensitive, and so on. So areas which are important or sensitive, areas which used by protected, important or sensitive species, inland, coastal, marine or underground water, and what all things have to be taken care of. So these sensitivity is also given. And then you would also use the current and historic data to understand this. So I've taken this snip from the case example of Sacramento River. So here you can see how they are putting their data to understand the historical perspective. Here also again you can see the historical data on how the changes are happening. So there's another example. You can see how you can look at the impact which happens on the receptor. So you look at the different magnitudes, you describe the nature of the receptor and look at the magnitude, and then you also find framework which is there to check this. So you can see this decision-making framework. How do you decide whether it's important, not important? So one of the framework has been given here. So even that can be referred here. And then there's another framework approach which is given, which is like Rochdale envelope, which is also very much used in the environmental impact assessments. So that can also be used here. So the link to this document, I have provided this for you. So that is what we saw about coastal area, what are the different impacts, and then what kind of models are used, and then what kind of questions you ask to really see the impact, magnitude and significance, and the sensitivity of the receptor. So what did we cover today? We covered the sources and types of impacts for coastal areas, then we looked at the methods for impact predictions and assessment. So that was the coverage for today. And this was the key reference, the book, Therivel and Booth's book, which is our textbook. And then, there are suggested readings and watch, like all the phenomenon and cases, which we could not discuss all of them, but then they have been given here so that you can look at those videos separately if you're interested. So we'll wind up there. So please feel free to ask questions. Let us know about any concerns you have. Do share your opinions, experiences, and suggestions. Looking forward to interacting and co-learning with you while exploring AI. Thank you.